Hello there, welcome to lesson number 4 in our series on using FluidDesigner for 3D printing to create rings. In today's lesson we're going to show you how you can create a torus ring. So if you start up FluidDesigner, we need to go to Learning Projects, Jewellery Projects, Rings. And we're going to do lesson 4, so it's 04 Torus Knot Plus. And we just drag and drop that onto the workspace. I'll just switch on the screencast keys, so any key presses I make should be displayed in the window here. And just remind you the instructions are in the help window on the left here if you want to follow those instructions rather than watch the video. So we're going to create this Torus Knot ring, and the thing about this is that there's just literally thousands of different torus knot shapes that you can generate in FluidDesigner quickly and easily once you learn the simple rules as to how to create them. That's all really. So what we're going to do? Well, in the help window it says add a curve Torus Knot Plus. So let's go to add curve Torus Knot Plus. And as is usual, the opening object is quite small, so if we go to view and zoom to selected, you can see what the initial object looks like. That's the initial torus knot. And what the torus knot means is that if you follow it all the way around, it will just come back and repeat on itself. So it's one continuous loop which loops in on itself. So that's what we mean by a torus knot. And as you can see at the moment, the size of this object, well, it's only 5.5 millimeters by 5.5 millimeters, so it's quite tiny at the moment. What is important is that this toolbox window is open, so if it isn't, you can just press T on the keyboard. T for toolbox will just open and close it. This panel here also needs to be open. If it's not open, you can just click on it. So what do we want to change? Well, we want to change some of the values in here to change this torus knot into the finished object. Well, the first thing is the resolution. Well, we're going to leave it at 100. The higher this value, the smoother the surface finish of this object is going to be. But the downside for making it very large, as you can probably see on the mouse there, you're going to make the file size very large as well. So at the moment, let's stick to resolution of 100. You can always play around with that yourself in the future. It will make the file size large, but it will improve the quality of the finished product. So the next thing is the height. Well, I think that's probably going to be pretty obvious. As we increase that, you can see the height in this direction, the Z dimension. Yeah, the Z value is the value that's changing. So it literally is changing the height of the object. Now in terms of the ring itself, what we mean by the height is this height here. So it's the depth, the height of the ring. Okay, so that's what we're changing at the moment. Now we want a height of 5, so if we enter in 5, notice that the Z value is 10.099. Don't worry about the 0.99 or 0.099 millimeters. This is essentially 10 millimeters now. So a height of 5 will give us approximately 10 millimeters here. And the reason for that is that the height is 5 millimeters in the Z direction above the grid and 5 millimeters below, giving you a total height of 10. So you've got to decide what sort of size do you want your ring. If you want it 10 millimeters, you need a height value of half of that, 5. So that's what we're dealing with there. Now the next thing we want to change is the scale. Now we also want to set the scale to be 5. Well, let's see what happens when we change the scale. Well, as you can see, the width of the object, so in other words, the internal diameter of the ring, is increasing. So the scale increases that value. Now I'm just going to type in a scale of 3 and let's see what happens over here. Well, the X and the Y, well, they're 13. Okay, let me change the scale back to 2 and see what they are. Oh, they're 9. Alright, in essence this value is a little bit more than 4 4 times the scale. 4 times 2 is 8. These are currently 9 at the moment. 9 being the external diameter of the object, of the ring in this case. So if we change it to 3, 4 times 3 is 12, so this is 12 millimeters on the outside. Now this is saying 13 because you've got the thickness of the ring as well. So if we enter in a scale of 5, what that's giving is a ring of approximately 20 millimeters on the inside. Now that will vary as we change the pattern of the ring and the thickness of the ring as well. So this is not an absolute value, but it gives you some idea what you need to do. Now the next thing that we want to change is actually a little bit lower down, and it's the bevel. If we zoom in on this object at the moment, you can see it's actually pretty thin compared with the finished object. This is going to be far too thin to actually print. But if we change this value here, the bevel, to 1, what we're effectively doing is creating a thickness here of 2 millimeters. The bevel is a little bit like the radius, the internal radius of each of these rings. So if the radius is 1, the diameter will be 2. So a bevel of 1 approximately gives you a thickness of 2 millimeters. So that's what we're looking for, a thickness of 2 millimeters. Now the next thing we want to change, or the last two things that we want to change, are the P and the Q values. Now I'm just going to go to view and view this from the front now, so you can see what's happening. We're in perspective mode as well at the moment, so I'm going to change that from perspective to ortho, and I'll just move the window up slightly so you can see. Here's the finished object. Let's see what happens when we change P and Q. Well, the shape changes, and as you can see, there are lots and lots and lots of different shapes that we can come up with for these torus rings. All the time we're changing P, the shape of the ring changes. So I'll switch it to view and front again. And we want a value of P to be 4. So let's see what happens when we change Q. Well, again, the shape of the ring changes. So the different combinations of these P and Q values literally give us thousands of different shapes for our Torus knot rings. So we're just going to create this one in today's lesson of P of 4 and Q of 7. But you do need to understand and take note that you can create all sorts of different shapes, whatever takes your fancy, whatever appeals to you as the finished shape. So that's the beauty of using FluidDesigner. That's the beauty of having these parameters here that you can change to change the object. Now once you're actually happy with the shape of the object that you've got and you don't want to change these values anymore, you can close this panel down. But because this object is a curve, we did add curve Torus Knot Plus, we can't print curves. Once you're actually happy with the object, you've got to convert it to a mesh, and we do that in FluidDesigner by going to Tools, Object Tools, and convert it to a mesh. Now once you do this, those parameters will disappear from this window now. You can't change those anymore, so you are stuck with this shape unless you go back to the beginning and start again. Now that doesn't take very long, but you know, there's not a lot of point in doing that. So what we want to do is delete this original object now, and let's have a look at the one that we've created in today's lesson. Well, if we view it from the top, and we are in ortho mode, so if we zoom in, what we need to do is we need to ascertain, we need to measure the internal diameter of this to make sure it will actually fit our finger, or your finger. So, oops, I'm scrolling across the wrong toolbar there. If I scroll across the toolbar here, I'm just rolling the center mouse button. If I click on interactive ruler, I'll get some idea of how big this is. Well, at the moment it's about 16 millimeters internal diameter. Now we need to, obviously we need to know exactly what size we need for your finger. But what we're going to say in this lesson is we're going to assume that you want an internal diameter of 20 millimeters. Now I'm going to go to view from the top again. Always a good idea to look down at it from the top and just zoom in. And in order to size this, what I'm going to do is I'm going to add, this is just temporarily, I'm going to add a cylinder mesh to the workspace. And if we assume that we want a diameter of 20 millimeters, that's the dimensions for your finger. If we type 20 millimeters for X and 20 millimeters for Y, what we've got there is a cylinder that's exactly 20 millimeters. So what we can do is we can scale up our ring until it just fits on the outside of that cylinder. So what we can do is we can click on the ring itself and need to double check whether or not I've got the Torus Knot. Yeah, I've got the Torus Knot ring highlighted. You don't want the cylinder highlighted, you want the Torus Knot highlighted. So I can just close that panel down again. Now in FluidDesigner we can scale by pressing S on the keyboard, and if I just move the mouse away now from the center, I'm scaling up this ring, and I need to look until it's just touching the outside of that cylinder, and then I can click. So I've scaled up my Torus Knot ring so that I've now got an internal diameter of 20 millimeters. But whenever you're scaling FluidDesigner, the resize vectors will always change. We've scaled up, so the real resize vectors are above 1 now, 1.259. These must be reset back to 1. We must set the vectors back to 1 before we print, and we can do that in FluidDesigner by holding down the control key and pressing A, and we apply the scale. And you'll see a little tick in the box here for scale. That ring is now in a format that can print. We don't want a scale factor of anything other than 1 for the ring. It can cause problems when it comes to printing. Okay, so there's the Torus Knot that we've created in today's lesson. We don't want this cylinder, so if we highlight the cylinder, press X on the keyboard and delete it. We can now save this Torus Knot ring. And as is usual in FluidDesigner, go to File and Save As. Don't save it in the Learning Projects folder, just go up through the menu system. Look for My Projects, Jewellery Projects Ring, and you can save for the Torus Knot Plus file. Save it as a Blender file. Now we can't print Blender files, so we need to export this in a printable file format, and we're going to use the Wavefront OBJ format. We like to save it to the desktop because that's just our habit, so it's 04 Torus Knot Plus object. Export that to the desktop, and then we always need to go to NetFab Basic and check this. I'm pretty sure it's going to be alright, but if we go to Project and Open and go to the desktop, 04 Torus Knot Plus, this is the object file, and if we open that up, sure enough, there are no issues with it. If we zoom in, you can see it is quite a sort of chunky looking ring, this, because we've only got, I think it was 8 faces around the object there, so it is quite a chunky looking ring, but we could change the resolution and we could change the number of faces around the object. But that's what we've done today. We're going to go to now Extras and repair the part to analyze this, and NetFab Basic will have triangulated this. So all these triangles have been created from the mesh that was in FluidDesigner. It's been done by NetFab. We need triangulated mesh to print, but if we just move the screen across and click Update, you can see there aren't any border edge problems, orientation or holes. FluidDesigner does a good job at creating this sort of object. The mathematics of it works well, but it's always a good idea still. We always recommend every time to go to NetFab Basic. So if we run automatic repair and execute it and apply the repair and remove the old part, only takes a second to do. This now, when we save it, we go to Part, export the part as a Wavefront object, save it to the desktop. So the repaired object file 04 Torus Knot Plus, that's the file that you would print. Okay, so that's it. That's the end of this lesson. Thank you.